Okay, we spent a good bit of time in the MCR class, and this is 16th of October. We had f of x equal x squared. We spent a lot of time looking at composites because this was somewhat confusing for people. Okay, f of x, x squared, g of x is 2 to the x. So the question was, what is f of g of x? And what is g of f of x? Well, put down that f of g of x was f of 2 to the x because g of x is 2 to the x. And g of f of x was g of x squared because f of x is x squared. But at this point, there was confusion, okay? When you're looking at f of 2 to the x, you're kind of looking at 2 to the x, and you're also looking at x squared, and it's not as clear as it might be exactly what you're supposed to do. So, I say f of x equals x squared. Okay, if f of x equals x squared, then f of aardvark has to equal aardvark squared. Why? Because you've replaced x with aardvark. Okay? So, if you replace x with aardvark in this expression, this is going to become f of aardvark, and this is going to become aardvark squared. Okay? Now, similarly, what is f of 2 to the x? Well, to get f of 2 to the x, you have to replace x in this expression by 2 to the x. So if you replace this x by 2 to the x, you get, of course, f of 2 to the x. And when you replace x on the right-hand side by 2 to the x, you get the quantity 2 to the x squared. Okay? If you replace every x in the expression g of x equal x squared with 2 to the x, what do you get? Okay? So that would be the answer to this question because you're calculating g of x squared. And why would I have called that g? That's a bit of bad notation. And really what I intended to do and didn't do, this has to be confusing. I'm not sure this is what I was intending, but let me fix this. Okay. Well, g of x is 2 to the x. So if we replace every x in g of x equals 2 to the x with x squared, what do we get? Well, we get g of x squared. And let me use the same colors I used before. Because we're replacing every x here with x squared. Okay, so we get, instead of x, we've got x squared. And then instead of x here, we have x squared. And we don't need these parentheses. What we're going to get is 2 raised to the x squared. And that doesn't equal this. Okay, so that got garbled a little bit. Again, if you replace every x in g of x equals 2 to the x with x squared, what do you get? Now, the statement I had previously was correct, it just didn't relate back to these functions. So there's nothing incorrect in the statement, but I had to change, I reversed the f of x and g of x accidentally, okay? Again, replace every x in this expression with x squared, what do you get? Well, you replace this x with x squared, here you have it. You replace this x with x squared, here you have it. So, g of f of x equals g of x squared, which we saw originally. But now if we replace every x here with x squared, which we have to do if we write g of x squared. In other words, what do we have to replace x by for this to be this? Well, this has g of x squared, this has g of x. So we have to replace x by x squared. And we replace x throughout this expression with x squared. And we get 2 raised to the x squared. So, f of 2 to the x is 2 to the x quantity squared, and g of f of x for these functions is 2 raised to the x squared. These kind of look the same, but the parentheses are in different places, and the meaning of the function is completely different. This function becomes 2 raised to the 2x squared, to the 2x. And this expression is, well, the exponent here is x squared. The exponent here turns out to be 2x. Completely different expressions. Okay. Now we'll look at another example.